Hey, good morning. Thanks for coming out today. My name's Nick Galbreath, and I'm going to talk about sort of the next generation or next revision of the libinjection library. Out of curiosity for context, how many people are familiar with it to begin with? Okay, whole two people. Cool. All right, well, I'll give an intro on it as well. So, what is the goal of libinjection? And it's really slightly ambitious. It's just to eliminate injection attacks altogether. Um, the correct solution is to validate inputs. It's not a technically hard problem, but it's definitely frequently a social and political issue in organizations and software. Developer education really is, I think it's great, but at the end of the day, one vulnerability is all it takes, so it isn't really comprehensive. And you have just a massive overhang of legacy applications, which are likely never to get fixed. So the goal is like, how can we eliminate a lot of this stuff? And a couple of years ago, I sort of end up writing a C library, which to detect SQL injection attacks, it works very differently than previous solutions. It does not use regular expressions. It actually parses the input as though it were an actual database. This was presented at Black Hat USA, I guess 2 summers ago. And it sort of like, as I said, tokenizes the input and then does some interesting matching and really fast. And IronB and Mod Security WAFs have integrated in. There's at least 2 or 3 honeypots that are using it. There's a couple proprietary firewalls floating around that are using it as well. And so the real reason is why did I do this in the first place? And really a couple years ago, some of my colleagues were trying to work on doing some detection of SQL injection into our application. And I was really amazed that there wasn't a library to actually do this. There was no standard way. There certainly was a bunch of things floating around, but none of them were actually measurable in how well they're working, or if they even worked at all. So I sort of worked on standardizing it, and a couple years ago, it was like 600 lines of code. I tokenized the input, 16 tokens, identified 600 sort of unique patterns that are definitely unique to sqli, and maybe a few rules to combine tokens and do stuff. And 2 years later, it's sort of ballooned into 8,000, sqli fingerprints. There's 30 rules to glue things together, 20 tokens, 400 unit tests, 85,000 samples. So it's actually very comprehensive now. And I still occasionally get reports of things that sort of slip through. This may look like, wow, it's going to be really slow, but really, you can get a 500,000 to a million checks per second out of it. So really, I think, an efficient way, elegant way of detecting sqli attacks. Along the way, I learned some other stuff. I originally started this by, hey, I'm going to get a bunch of sqli scanners and figure out what they do and use that for my training data. And I learned very quickly that the commercial tools and sort of open source tools to sort of do sqli attacks and scanning are in no way a replacement for a skilled hacker. And so a couple people, this guy, R. Salgado, would just every day just wake up and just blow through my stuff continuously. So, attack-driven QA or attack-driven, development, if you're doing something in security, having someone who just actually just pounds on your stuff is absolutely a very efficient way of doing it. It's kind of like pair programming, but more fun. Anyway, so it's sort of, you can go get it right now. It's the main website's libinjection-client9.com, and from there you can link to GitHub and a few other places. And if you can't remember anything, client9.com is where it bounces to. And sort of my Twitter is down here on the bottom. So that was the last 2 years. XSS, the other white meat, the other injection, which is sort of the common one. And again, this is a really common problem. I'm sure you've all been hearing about it today. What can we do? What can we do? So breaking it down, just sort of like everything else, cross-site scripting is actually 2 things. One is attacks against the HTML like parser, tokenizer, And the other one is attacking JavaScript code, and they work very differently. So this is sort of I call this HTML injection. Please correct me if I'm using some incorrect terminology. User input comes from somewhere, command line, post args, query strings, whatnot, and somehow it gets inserted into different areas. So it could just be right into the page, could be sort of where an attribute is, could be in an unquoted value, single quoted, double quoted, and for IE only, there's sort of this backtick version. I guess you could also have cross-site scripting and comments, HTML comments, but I just don't think that's too common. You tell me. So that's sort of where HTML injection is, and these are attacks against the tokenizer itself. And the goal is to switch the context into sort of the JavaScript processing context, right? Where you can then do whatever you want. And frequently, what you do with the code is ever increasing. I saw a really nice HTML5 presentation yesterday. Like the nature of the attacks just keep getting more and more interesting. But at the end of the day, the actual sort of way you switch to JavaScript is pretty much the same. You got to sort of break the tokenizer and switch to this mode. Once you're in that mode, anything goes, right? Cool. So detecting these tokenizer problems seems feasible. Like we should be able to do something here. What is different, the other one is sort of the JavaScript injection. These sometimes are like DOM attacks, but could be some other weird things where you're auto-generating CSS from your program or dynamically generated JavaScript. There's lots of different sort of bizarre things developers do. But the difference here is user input is going into the JavaScript program directly. There's no trying to switch context. You're already in JavaScript. And these are tough. These to me seem like these are hard. These are attacks against JavaScript code. And as you know, JavaScript is super dynamic. Just the way it works is not like SQL. SQL's nice in that you input bad SQL, things break very hard. JavaScript is much more forgiving on errors. It has a bunch of very strange rules where you can obscure it sort of very naturally. There's a whole bunch of ways of obscuring JavaScript. Can't really obscure HTML quite the same way. If you haven't seen the JavaScript sort of obfuscators, check them out. They're really, really different. So detecting, I think, JavaScript fragments or partial code that come in is a really hard problem. I did it for SQL, but it's very different for JavaScript. So I think that one's going to be tough. So what are sort of the current solutions for detecting cross-site scripting? And the one I see frequently by security people, oh yeah, use HTML purifier. Use something that strips out stuff and does HTML, which is great. I'm sure some of them work fantastically well. The problem with this solution is it's completely disconnected from reality. Most inputs are not expecting pure HTML or even HTML fragment. And a lot of them are great. If you're expecting HTML, these purifiers are great. They're whitelist only. Here are the tags I will accept. The problem is cut and paste your email in. Great, I'm going to have my email name rejected because it's not a proper HTML tag. It's actual rejecting user inputs. And what happens with people, they do these sort of like filters and blacklists and stuff like that. Do you know how they work around false positives? They unplug it. They just get rid of it. So false positives are really important. And actually, back to the SQL stuff, that's one of the reasons. False positives, when you have them, engineering managers and developers, if they're getting bombarded by false positives, they solve it by unplugging it, just removing it altogether. It's actually really common. In static analysis tools, all this stuff. When you start seeing the false positives, they pull them. So it's really easy to write a perfect detector, return true, right? It will detect every cross-site scripting and everything else. So really making something accurate and precise is really important. The other sort of gotcha of these purifier libraries is they're language specific. They're fairly large, frequently slow. So I don't really see them as a practical solution, except in specialized cases. See, the other one are, I should have probably cut and pasted some. There's a million sanitization functions, which attempt to sort of delete things that look problematic. It somehow attempts to turn something that looks like cross-site scripting into something benign. The problem again with these is frequently removing things creates its own problems. You can remove things and the remaining two halves combine in and cause something else. I don't know why you want to make something benign as opposed to rejecting it. If you think something's malicious, why not just stop it right there? So I find this to be somewhat problematic as well. So the other problem is a lot of them are based on regular expressions, and that's fine. The problem is they sometimes glue together a million patterns with an OR operator, which makes, if you do get a false positive, how do you edit this compound regular expression function? It's this long. It's very difficult modifying something and knowing if you didn't break something else. Almost all of them had like no unit test cases, so if you did edit something, you don't actually know what you were breaking. Very difficult, having a hard time dealing with escaped input. There's just a million ways to escape HTML. Actually, not a million, there's a few, but it makes it very difficult to sort of do a regular expression based on this. So these are also somewhat problematic. Who are the vectors of XSS attacks? This is like, where do XSS attacks actually happen? This is sort of a trick question because it's completely obvious. They happen in web browsers, right? And if you've been in sort of the biz for a while, how web browsers work and process have been a nightmare for web developers. However, and even now, every browser's got its own sort of proprietary extensions to this or that, but actually they've converged quite a bit in one key area, and that is how they actually parse or rather tokenize HTML. And while there are some exceptions, it's pretty small. They almost all run now on the HTML5 tokenizing algorithm. It's just taking characters and turning it into chunks of stuff. So that's actually good news. And what's interesting is over the last couple years, if you sort of do the math, at least over 65% of the browsers are HTML5 compatible, and the ones that aren't are on their way out. And actually, I think it's more like 75 to 75. This is a little off. You can just see here, I pulled this from the Next Web. IE6 at 4, IE7 at 2%, IE8 at 20%, but really it's maybe more like 10% for most places. So you got IE9, 9%, IE10, 10%, IE11, 10%. You got Firefox total at 18. Maybe there's 2 or 3% out of that are really old. Chrome browsers, same thing. There's even they're more up to date than Firefox, so maybe 15% there HTML5 parsers. Safari, same thing, maybe about 5% are HTML5 parsers. So at the end of the day, all this diversity in browsers and the sort of the browser wars, great competition. What's interesting is they've converged though in how they do some basic handling of stuff. So the ones that don't use HTML5 are mostly IE. And there's only a few versions of IE. They don't release like Firefox and Chrome do. So the tokenizer actually doesn't change that much. They have very special exceptions. And HTML5 is sort of designed to match existing behavior already, so it's not that different. And just sort of going into some more detail here, IE's got 2% of market share, and everyone's web development nightmare, IE6, that's, these guys are both running probably on 10-year-old machines. I'm personally not that interested in protecting them. They're probably already owned already, so great, they're another XSS attack. There's nothing more to do. So they're going to go away. IE8's a bit more problematic. Depending on what you read, it's 10 to 20% of total volume. The good news is it can only go down. It's never going to go up. IE8 is the most modern browser on Windows XP, so that's probably going to slowly collapse over time. The other one that I sort of didn't mention previously is Opera browser, which I know is more popular in some particular countries. But even that 1.33%, maybe 40% of that is embedded systems. Opera for a while was doing everything different they possibly could. There was no experimental feature they wouldn't put in. They've since sort of dumped their own engine and sort of switching over to the WebKit Chrome engine. So it's too small to worry about. And so the reason I mention all this is I'm going to introduce first time libinjection and cross-site scripting, and I'll be a little pompous and say it's XSS detection for the future. It's only focusing on HTML injection attacks in HTML5 clients. And the reason this is important is I'm trying to define what I'm solving. I'm trying to actually have a goal as opposed to some sort of nebulous solution here. Picking my own battles. So a lot of the things I've seen in other sort of open source functions that try and do sanitization or even attack proxies and all this other stuff is in the mix of all this is HTML XSLT injection. Different problem. Very different solution too. Ton of stuff for IE6, IE7 Opera, really old versions of Chrome, don't care about. DOM style attacks, things that are attacking JavaScript, I really think those are better handled in a client solution. And you've seen certainly Chrome and IE actually have some solutions in their browser. And you've seen some solutions for JavaScript libraries that get loaded in to try and detect these type of attacks. So if I'm only focusing on just sort of the HTML injection, I think we can do an all right job. And this is the technique, and it's pretty much very similar to the SQL one, is I'm going to parse user input in a number of different HTML contexts, and I'm going to get a series of tags, attributes, and values, just like a browser would. And then I'm going to ban the various things that are problematic. Sounds fairly simple, but it's a little different. This slide is really awkward, and I need to reword it. The difference is you just have an arbitrary library that just works on detecting cross-site scripting. You sort of a priori have to know what cross-site scripting is. Like how can you test it? How can you write tests against it? What is cross-site scripting? It's like, well, it is what I detect it is. It's a little pedantic. Tautology rather. What I'm actually doing here is detecting XSS. I'm shifting it to another problem. Can I tokenize HTML5 correctly? This I can 100% write tests against. And if I can tokenize HTML5 really well and write tests against it, the detecting XSS part is really much smaller. It's a much smaller problem. So this is great just for engineering. I can make sure that this actually is exactly the same as a browser, how a browser would treat it. It's really sort of a software engineering issue. Like, how can I write tests against something? How do I know I'm doing it correctly? And by shifting the problem onto something we can solve, it makes the hard part simpler. Anyway, it turns out, after talking about this, tokenizing HTML exactly how a browser does it, it turns out to be not that much work. And that is because, let me tell you the stuff that's hard, because you might go, once you get a bunch of tokens, turn it into a DOM tree, hard. A lot of big spec on that. Handling broken nested tags, hard. Defining the exact operations, how script tags work. Defining what tags do. Rendering, hard. Those are hard. But the tokenization turns out to be easy because the HTML5 spec lists every state. It provides a super pedantic state machine of exactly, given this character, here's what you do. And it's pretty nice code. And when you see it, I don't care what programming language you're familiar with, you can do this. You can read this as well as anyone else. The language is a little funny, but it's very clear. Completely not ambiguous at all in what happens. And this is why in HTML5, like the rendering, the parsing step is really nice between different browsers. Because this can actually be, there's a number of libraries that do this. It's pretty straightforward. So what I end up writing is actually a full HTML5 tokenizer. It doesn't build a tree or a DOM. It's not like your Saks XML parser or something like that. It just emits tokenizing events, no copying of data. And so a sample, if you make it more or less abstract, it's very basic. Tag open, image, attribute name, source, Not the most interesting example, but it will also handle all the cases where, oh yeah, there's different versions of white space and control characters intermixed here. Things that are HTML escaped in various formats. At the end of the day, no matter how this is encoded, you would still end up in this format. And with different contexts, I started sort of in the main sort of context and got the open tag. But I could easily start the context here, say, hey, I already opened a tag. And it would still emit sort of the same type of events, very clean. Everything's the same, no matter how you parse it. So once you have this, getting problematic tags and attributes and values, pretty straightforward. And this code is actually really small and really easy to read. I could pull it up. The usual things you expected are banned. Script tags, on event handlers. But what's great about it is, sure, it's a blacklist and maybe things need to be changed a little bit. If it just sees the word on error, image source, on error, do some JavaScript, just the word on error by itself isn't enough to trigger, hey, that's SQL injection, like maybe a regular expression might. It needs to be on error with the value. So there's rules on how that works. Equals, how does the quoting work? How does the end the quoting work? So this should really work on better reducing false negatives. Really, blacklists are kind of not optimal, but I don't really know how else you're going to do it. There's a very clear list of tags and attributes that are problematic that you just need to nuke. This list is probably going to need refinement over time, so we'll work on it. The other thing too, as mentioned, this is going to go through and actually parse this in multiple different contexts. So the code actually is going to reparse your input in 5 or 6 different contexts. Hey, is the context right in the middle of the page? Is the XSS injection in a double quoted thing? Is it a single quoted thing? Because there's very specific rules now on how quotes are terminated. Back, like Firefox 3 days and, all the different browsers, they'd all have different rules on how to break out of things. So you had all these different escapes. Not true anymore. It's very standardized. It works really nicely. Again, there's some weird exceptions with IE, and we'll discuss that in just a minute. So I got all this. I have my algorithm. I have my blacklist. How do I know it works or doesn't work? And this is what I pulled out for how to train the algorithm. One other thing I was surprised by is the cross-site scripting cheat sheets are really outdated. I don't see Robert Hansen in here today, but his old cheat sheet, Snake's cheat sheet, came out, I don't know, maybe 8, 9, 10 years ago. And it's still published as the cheat sheet under OWASP. Unfortunately, I'd say a good 30% of the content in there doesn't work anymore. Hasn't worked in 5 years. So I had to go through each one of the things and actually validate that these, attacks actually are still valid. It's actually kind of interesting. We have obsolete attacks. Most of the SQL attacks from 10 years ago work just fine right now, which is kind of interesting. So going through some of the cheat sheets that exist, make sure things are still valid. Another source, this site's really good, and I hope I typed it right, html5sec.org. It's a really cool resource. It really has cataloged, here's a SQL injection, cross-site scripting attack. Here's the browsers it worked for, and here's when it stopped working, and it really goes through a lot of details. It's a really fantastic resource. The good news is it actually lists if something's outdated. Hey, this only worked for this version of Opera or Firefox. They had one bad release and it did this. Like, they'll list that. I had to pretty much prune out all that stuff because it just doesn't matter anymore. This guy, unfortunately, I forgot his actual name. You should definitely, if you're interested in this, you should follow him on Twitter. He produces new cross-site scripting stuff regularly in his Twitter feed. He loves cross-site scripting. I think he's working on a PhD thesis, and it's pretty clear he lives and breathes this stuff. He's produced, here's my top 10 things I go through and scan, sites on. So definitely worth following, and he produces some nice decks and top 50 lists and whatnot. Another sort of source are current sort of like attack scanners. And so far I've only actually integrated one. Basically I set up an empty website, let it run, see what it pulls, see what it's pinning, and grab that. I really need to grab some more of these. So at the end of the day, I collected over 1,600 total samples, and so worked on working on the blacklists and whatnot, and ended up with detecting nearly all of them. And what's interesting is the ones that are left actually all are more or less the same thing. It's some weird quoting rule that I'm not familiar with. It's something to do with unbalanced quotes in IE. It has an exception to the HTML5 parsing rules. So if you got a Windows machine with IE8 and IE10 on it, feel free to stop by. It'll take 5 minutes for me. I'm going to have to go out and buy a Windows machine just to really test it correctly. But other than that, it's worked fairly well. Where was I going with this? Blah. Okay. So, reprocessing things 6 times in 6 different contexts. I was fearing this would be slow. It turns out not. Over 500,000 again per second. Actually, on this laptop, I'm getting over 1.3 million per second. So it's very efficient doing this tokenization. It's not copying, and the reason is you're really just looking for single quotes, back quotes, greater than, less than sign, and if it doesn't have that, basically each check doesn't do anything. It's like, oh, it's just HTML data. So it runs really fast, and that's certainly good enough for any type of, I think, internal WAF you might have or web app you have. So I'm gonna get done a little early here today. I've been sort of distracted the last few weeks. I was hoping to get this a touch further. It's an alpha, so there's likely, given my past experience, to be spectacular bypasses. So this is sort of the announcement. Here's the call to arms, like, go break my stuff. False positives, QA isn't quite complete. As I just mentioned, doesn't handle some IE injections. I haven't quite hooked up the code coverage I've done with the sqli stuff, but I know the HTML5 stuff's pretty solid. And I haven't hooked up bindings for scripting languages. The sqli stuff, I have bindings for PHP, Python, maybe Lua. So if anyone wants to help with that, it's probably not a lot of work. We can do it after here. So I'm going to get done a touch early. One thing that was interesting is when I was tuning this against actual attacks, almost everything that slipped through turned out to be a bug in my HTML parser. So it was a very good validation. Every time I made a bug in my HTML5 parser, oh, lo and behold, there was a cross-site scripting attack that actually leveraged that bug. So doing this well, I think we can get a pretty good step on capturing cross-site scripting. Would this work in other scripting languages? Could we port the C code back to other scripting languages to make it easier to do? And I think it is. It's much simpler than the SQL code. The SQL injection attack code is really pretty tough. SQL turns out to be a really hard language to parse and process. HTML token's pretty simple. So if anyone wants to work on a port, I don't care what language it is. Python's my fave, but I'm happy to do it with anyone else. It'd be great. So anyway, I urge you to take a look at it. It's free. It's a BSD license, so you can hack away on it all you want. And here are the two main websites on GitHub and libinjection at client9.com. And if you got any questions, I'll take them. It's a little early, so we'll have a super long lunch. Questions, comments, thoughts? I'd really love to get people getting this code on their website, and even just for logging to see what the validation is. If it's capturing stuff, is it not capturing stuff? Too many false positives. Let's get going and see what's going on. Yes? Yeah. Oh, sorry, it's in C, but it's pretty straightforward when you read it. You almost can type it PHP, Python, or whatever almost directly through. Don't go too far forward, I guess. Okay. Any other questions? Yes.
So how does it do the scanning locally on the system, or?
Oh, okay. So my envision is you'd actually put this in the beginning of like whatever framework you use and say, hey, I got the query string. You just run through your key value pairs and throw it in, and you can see what it does. I can certainly fire up a terminal, once I put the mic down, we can go through it and see how it works. Yeah. So again, like both of these, the question was like, how do you actually use it? And you'd sort of probably put a scripting language binding in, and at the beginning of your app, you just run through the key value pairs of the query string or your post arguments, and it's literally libinjection is XSS input, and it will return true, false. The SQL code is a little different. It returns a little more information because it's a harder problem. And it's really that simple, just one line. Yes?
Have you done anything to look whether or not it's going to have false positives?
Only a little bit. And so far it was pretty good. I do have an input from about 200 million sort of real world inputs from a large website. And run that through for the SQL and cross-site scripting. And so far, pretty good. Actually turned up some new attacks. This is from a couple of years ago that I didn't know were happening at the time of the company I was working at. So it seems to be pretty accurate, but I need to really post that. Anyone a C programmer here? Boo. Oh, one person half raised their hand. Two. Okay, two. Yeah. Okay, cool. Yeah, really need to work on some bindings to really make it more available for everyone else. But this, I think, mere mortals can understand. The code is not too complicated. Cool. Well, hey guys, thanks for showing up. I urge you take it to your dev team. If you're not a C programmer or you can't do a binding, take it to your other development team. Let them take a look at it and try and get it in. Because just knowing attacks are coming in is really that's the job. That's the start of the job, right? And having an accurate way that isn't bombarding with false positives, I think, helps everyone. I normally don't use these in blocking mode, just detecting. Most of your website doesn't have problems, so I just let them go through and waste their time and then focus on where they're sort of looking at. So plugging this into graphing or anything else, a really powerful way of seeing what attackers are doing. Cool, guys. Well, hey, enjoy the sun. I'll be downstairs.